Hello everyone, welcome back to my channel. Today let's go over a Leetcode hard question that I just solved on my own. So I'm super happy about this and I'm extremely glad that I was able to come up with my own solution to this question without any assistance. So let's go over it and let me show you how I did it. This is 1147 longest chunked palindrome decomposition. So basically you're given this string called text and you want to split it into as many strings as possible. So just by going from these rules, if we look at the example, you'll observe that as soon as you find the same thing, so hence the name of the actual problem, palindrome, if they're the same, then move the pointers in and try to find all the ones that can be the same, right? A, B, C, D, F. And then from here, hello, and then last but not least, Adam. So notice that the string has to always at least be one, and at least if it has something, which it is, because it has to be at least of length 1 if we look at the constraints. And same here, so A is the same as A, and then also NT is the same as NT, so we're just going to start from both sides and keep moving inwards. This is the classic two-pointer approach, right? So yeah, so let's go ahead and do that. So left, right is 0, length of text minus 1. So let's call this left side and right side because we're going to have two empty strings, and as soon as they're equal, then we're just going to set them equal to whatever we have so far from the left side, and from the right side. And then we're going to make the left and the right bars from onwards, not from the beginning, because we only want what we haven't yet tracked, right? So I hope that makes sense. So that was my way of sort of approaching this problem. And so let's go ahead and try to code it up. So this is going to be, let's call this left margin or left boundary, and right boundary is the same thing, minus 1. So while left is less than right, we're just going to ask, so the left side is just going to be text of left boundary up to L plus 1, and the right side is just going to be text of right boundary or of R to RB plus 1. Okay, so let's go ahead and print the left side and right side. And let's just go ahead and do this so we don't get an infinite loop. Okay, so you can see, so if the left side is equal to the right side, then let's go ahead and print this. So we're going to have an answer, and in that case, we can go ahead and increment answer by 2 because that's two separate strings that we've parsed that are equal, right? So we want to count how many substrings are in total. So that was kind of my thought process as I was sort of looking at this problem. So cool. So in that case, once we do that, then we're going to update the left boundary and right boundary. What I just did is just did left plus 1, right minus 1, because we're going like this and like this with a left and right pointer. So I just said, you know, this is the most obvious way to do it, and it's pretty intuitive to me. So that's how I did it. And then from that point, obviously we have to clear left side and right side, right? And if we print this, we can see we get all the strings we need, which is great, except at the very end, let's print the last string. Let's just call this last string. That's what I did. So I just said, let's just, well, we can just do it anyway. So at the end, if left side is less than or equal to right side, then we can just return answer plus 1, because that means they haven't touched each other yet, and there's still one more substring because it at least has to be of one substring, right, in the middle. Otherwise, we just return answer because there is no substring in the middle. If they've crossed, for example, like left is to the right of right and right is to the left of left, which means we don't have a leftover substring. Okay, so let's run this, and you can see that's not correct. So if left is less than or equal to right, because those are the pointers we're working with, and it looks like, let's go ahead and print left side and right side Or let's go ahead and print left boundary and right boundary. Sorry, that's what we're looking for. Because left boundary and right boundary are supposed to be sort of the indicators of the kind of progress we've made, right? Because as soon as these are equal, then we're going to set the left boundary here and from here, and then we're going to set the right boundary here from here originally, right? So, yep. So hopefully that makes sense. Let's run this and submit it. And there you go, passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any help and solve it completely on my own. So that's it for this video, and thank you for watching.